Our next speaker is Sanjeev Khanna from Microsoft. I met Sanjeev, I think, for the first time in Macau this past year, and he shared with us sort of the vision that Microsoft had for OCS and what they were going to be doing with that in the future. And I think that, especially in retrofit environments and legacy environments, it's very hard to adopt a 21-inch open rack standard 48-volt DC in the back. There's a lot of companies that really need to consume 19 inches, but want to take advantage of all of the principles inside of Open Compute. And Microsoft has really capitalized on being able to do that. So next up, please help me welcome Sanjeev Khanna from Microsoft to talk to you about OCS and growing that ecosystem. Sanjeev.
Hey, good morning, everyone. I think it's still good morning. So welcome after the break. Hey, so I'm going to talk about and take a little different things than you've been hearing about different technologies and different contributions that different companies have done. My discussion is about what Microsoft has learned through deployments of OCS and what are we doing to enable our supply chain and the ecosystem. So it's a bit different, but it's hopefully the goal is that the things that we have learned that you can apply in your environment. So when we think about capacity or delivering the hardware, which is going to start taking the cloud services, we have to sometimes start thinking about 5 years out and start taking some bets which are about how we're going to go deliver a server when it is needed. So things like subsea cable. So my team negotiates subsea cables for Microsoft. And that discussion is usually happening 5 years out. The consortium gets set up, and then the cable has to be put in the water for that to happen. Then we have to go buy land and build a data center on top of it. That is usually, again, 3 to 4 years out. We are looking at where the demand is and negotiating with the local authorities and then go build data center on top of it. The next is energy. Depending on where the land is, where the data center is, at minimum, we need a substation because our workloads require lots of power. But it also could require a transmission line which needs to be pulled from the nearest station to where the data center is. So if you can imagine, that's another 24 months minimum. And there are no substations sitting on anyone's shelf. So people have to go build the substation, deliver it, and so we can deploy it for our data centers. Dark fiber discussions are usually happening 12 months to 18 months before we turn on servers. And next is network hardware. All the network stuff has to be in place when the servers land. So that's another 9 to 12 months out. So as you can see, right, before we go and start deploying any kind of cloud services, we have to go look out all the way up to 5, 6 years. And then comes the servers, which is 4 to 6 months out. But servers are the single largest spend in any kind of large data center deployments. And that is, even though the time is short, but given that it is so important, this is why we started looking into the OCS type of platforms. Yesterday, you heard Kushagra talk about what we are doing technology-wise in OCS and our version 2 contribution to the community. Today, I'm going to talk about, on the supply chain side, how OCS is helping us and what are we learning and putting in place for our own data centers. So server supply chain is complex in general, And when you run a cloud scale business, it gets further complex. We have more than 200 different cloud services that run in Microsoft data centers. We have a global operation. We announced that we have more than 1 million servers across the globe, which we are deploying and managing on an ongoing basis. And we need to have a continuity of supply to make sure that we are delivering the workloads when we need to. So what was happening pre-OCS is we had many platforms. Every platform from different system integrator had its own set of components which were on their AVL. And what it required us to was to make sure that each particular platform worked on our cloud services. So the validation effort was massive. And then you had to go and validate the components, and the components were different for each system integrator. So you got to go make sure that each component works with each platform. So given that, not only was it expensive, time-consuming, but it was also a challenge for us that we couldn't take advantage of the new technology and be time to market when we wanted to be. With OCS, we are able to deliver one single platform, regardless of the system integrator. We have to do validation only once. And then we can have a set of components that we select and validate on those on those platforms. And those things can come together, and we can deliver it for different services. Ideally, as a supply chain guy, I would like to have every platform which runs on exact same SKU. It's exactly same configurations. It has everything exactly the same. It makes my life easier. But that is not practical, sometimes for cost reasons, because you don't want to go and throw in extra SSDs where you don't need it. Or for technology reasons, because you might need 18 DIMMs or more DIMMs in a platform, and you're not delivering those. So given that there are those things that we need to take, we need to look at those things. So we are looking at one platform and then many components so they can be configured for different workloads. Next piece is the global data center or the footprint with 1 million+ servers. That has to be, that's the biggest challenge we had was pre-OCS, is manageability. Every platform vendor or system integrator had their own manageability suite that had to be worked into our software. That took time, we made mistakes, and that during deployments, that caused deployment risk. Then we had to go and build site-specific material because there are different PDUs, different requirements in different sites. So it's a cost, it's a different effort. And lastly, the operator training. Each operator had to be trained on different platforms. These things are not fungible, and operators were always learning a new thing. With OCS, regardless of a system integrator, we have unified system manageability. So it doesn't matter if it's who does the system come from, the manageability is same. We have to write our software once on top of it and manage it. We're reducing site-specific material. And lastly, the operators are trained on one platform, and they can go deeper into learning the platform versus always a new thing. And as operators get deeper into the platform, they can help solve problems. They can get the systems up and running a lot quicker than what we've been able to do in the past. And the next is the continuity of supply. Again, goes back to too many platforms, too many components, unique set of inventory, and then excessive, which causes excessive single points of failures. Because if you look at all the pieces that need to come together, the combinations of permutations you can have in the platform, if you do not have one single component available, or if there's a lines down anywhere, the service could be down or the rack could be down. And every time rack is down, that's basically we are not making money on those racks. So with the help of OCS, we have one platform which we can go from system integrator A to system integrator B and continue. In case there's an issue with the supplier A, we can easily move to supplier B without a hiccup. And we all live in a hardware world. There will be supply chain hiccups, but we need to be ready for those. Then we are managing our components list. We want to make sure that we have broad list so we are able to deliver the broad workloads that we need to. But at the same time, we want to make sure that it's managed and it's not something very exotic. We have a shared inventory now, so we can go into and use the inventory that we have built only once, not 3 or 4 or 5 times. In the past, it was interesting that we would have, let's say, a DIM, which is very simple product, if you would think, but we could not use DIM if it came from a supplier A, then that DIM has to be used for that only supplier A products. If supplier B needs a DIM or the server needs a DIM, you couldn't replace it, you couldn't use it. So we had 3 or 4, 5 different sets of inventories. We are reducing single point of failures by managing a list. And of course, there's a cost, that we're reducing cost on our side. So going through all this process, what have we learned? If we want to be time to market, we need to be engaged with suppliers very early into the production cycle. Because if we are late, and if we let supplier develop the platform, and then we start validation process, we will never be time to market with new technologies. Supply chain and operations need to be integral part of the design cycle. Because engineers like to design exotic stuff, but we want to make sure that my team is sitting there with engineers, and we're talking about that, what do we need in a supply chain side? Don't go and design something that we are not able to get. Don't go design anything where we cannot find multiple suppliers. On the operations-wise, operations teams had a seat at the table, and they're guiding our engineering team on, after we deploy these products, what are the impacts, and how can they take that feedback into the design cycle. And the choices are required. Choices are needed for continuity of supply and for us to manage our cost. Competition is good. We need suppliers who are competing for our business. And on a continuity of supply, we do need to make sure that there are multiple platform suppliers, there are multiple component suppliers who are helping us run our data centers. So with that in mind, we have been working with OCP community, and for OCS, we have several different system vendors who can deliver OCS to us as well as to others. And on a component side, this is not a complete list, but we have different component suppliers who are working with us to deliver a bunch of components that we can pull together to deliver services that we need to. So, in summary, what we've been doing is we've been working with our ecosystem to make sure we have a rich ecosystem to deliver services for Microsoft. But at the same time, we hope that you can leverage from the work we have done and use that in your deployments. Thank you. Hey, thank you, man.
So great to see how companies like Microsoft are taking advantage of this platform and driving that message forward.